Okay, get ready for this, because it's a bit of a mind bender. What if I told you that a brand new, absolutely tiny AI model is running circles around the biggest names in the industry? And not just on any tasks, but on problems that require deep, complex reasoning. I know, it sounds kind of impossible, but the results are in, and they are just staggering.
Just look at this. This is a benchmark for solving one of the hardest types of Sudoku puzzles out there. A new model called HRM, that's Hierarchical Reasoning Model, is hitting 55% accuracy. Now look at its competition. We're talking about the heavy hitters, right? Claude 3, DeepSeek. They're all scoring a big fat zero. Not 1%, zero. How does a new challenger just show up and do that?
Well, here's the first clue, and it only makes the mystery deeper. This new model, HRM, has only 27 times million parameters. That is tiny. We're in a David versus Goliath situation here, except Goliath is measured in hundreds of billions, maybe even trillions of parameters. This thing isn't even in the same weight class. So that brings us to the big question, the one we're going to unpack right now. How on earth is this possible? How can a model that's a fraction of the size and trained on way less data just completely outperform the titans of AI? Well, the answer lies in a totally different way of thinking about what it means for a machine to think. See, to really get why HRM is such a breakthrough, we first have to pull back the curtain on a little secret about today's big AI models. And the secret is, they don't really reason, at least not in the way we do. What we see as reasoning is actually more of a very sophisticated illusion. This here breaks it down perfectly. You ask a person to multiply 27 by 25, and they follow a set of logical steps to get the answer, 675. An LLM doesn't do that. It doesn't calculate. It predicts. It's looked at trillions of examples from the internet, and it just makes a very educated guess about which number is most likely to come after 27 times 25. It's a world-class pattern matcher, not a true reasoning engine. Now, researchers have clever workarounds, like something called chain of thought, where you basically ask the model to talk through its steps. But as the creators of HRM point out in their paper, it's not a real fix. They call it a crutch. It's this fragile, brittle process where if it makes one tiny mistake early on, the whole thing just falls apart. So, if that's the wrong way to do it, where do you turn for a better idea? Well, the researchers behind HRM looked to the best problem-solving machine ever created for inspiration, our brain. They decided to build an AI that doesn't just copy human language, but actually tries to copy the structure of human thought. The key idea they borrowed is something called hierarchical processing. It's exactly how our own brains work. Think about it. We have these high-level, slow parts of our brain that are all about the big picture, making plans, setting strategies. And then we have these super-fast, low-level circuits that just execute the nitty-gritty details of those plans. It's a two-speed system, and it works beautifully. The best way to picture this two-speed system is with a simple analogy. Let's say you're building a massive skyscraper. You don't just have one person trying to do everything, right? You have two critical roles. You've got the architect and you've got the engineer. The HRM is built with this exact same structure. It has what's called a high-level, or H module. That's the architect. It thinks slowly, carefully, and sets the overall game plan. Then you have the low-level, or L module. That's the engineer. It works incredibly fast, crunching the numbers and executing all the detailed little steps based on the architect's blueprints. And here's where the magic happens. It's a constant feedback loop. The architect sets a plan. The engineer then blasts through hundreds of quick computations to try and execute it. Then, and this is the key part, it reports back. The architect looks at the results, sees what worked and what didn't, updates the master plan, and sends the engineer back to work. This cycle repeats over and over, letting the model think deeply, correct its own mistakes, and explore really complex ideas without getting stuck. The point is, this whole brain-inspired design isn't just some cool theory on a whiteboard. It gets absolutely stunning results. It doesn't just work, it completely dominates, making a powerful case for a whole new way of building AI. Take the ARC-AGI benchmark. This isn't about memorizing facts. It's designed to test for real, fluid intelligence. And look, HRM scores over 40%. That's way higher than much bigger models like O3 Mini and Claude 3.7, which really seem to struggle with these kinds of abstract puzzles. And we're back to that insane Sudoku chart. Now you know why this is happening. While those other models are just trying to guess the next number based on patterns they've seen, HRM is actually working the problem. It's doing a deep, iterative search for the solution, kind of like a person would. And the results? A 55% success rate versus, well, 0. It's the exact same story with complex mazes. Finding the one perfect path in a huge maze requires a ton of searching and backtracking. For a normal LLM, that's pretty much impossible. For HRM, with its architect guiding the search and its engineer blazing the trails, it nails it almost 75% of the time. The competition? Again, 0. So what does this thinking process actually look like? The researchers gave us a peek inside. When it starts solving a maze, at time step 0, you can see it doesn't just pick one path and hope for the best. The engineer, guided by the architect, starts exploring a bunch of different routes all at the same time. Just a few steps later, by time step 3, the feedback loop has already kicked in. The engineer has reported back on dead ends, so the architect updates the plan. You can see it pruning away all the blocked and useless routes. And out of that chaos, the shape of a real solution starts to emerge. And finally, by time step 6, after a few more cycles of planning, executing, and revising, the model zeroes in on the single best path. This isn't just pattern matching. You're literally watching a structured, computational reasoning process unfold. Okay, so the performance is clearly off the charts, but the implications here are much, much bigger than just solving puzzles. This could be a fundamental shift in how we approach building intelligent machines. And here's the holy grail. A standard AI model is not Turing-complete. That's a fancy way of saying there are certain types of problems it simply cannot solve, no matter how big you make it. But the HRM, because of this back-and-forth cyclical structure, it is. In theory, given enough time, it can solve any problem that is computationally solvable. That's a massive leap. And really, what this all boils down to is a direct challenge to the way things have been done. For years, the mantra in AI has been, scale is all you need. Just make the models bigger, throw more data at them, and they'll get smarter. HRM's insane efficiency and power at such a tiny size suggests that maybe architecture, the design, is just as important as size, if not more so. Which leaves us with one last, really provocative question. This tiny model, inspired by the human brain, just solved problems that our biggest, most expensive AIs on the planet can't even begin to touch. So you have to wonder, have we been building AI the wrong way all along?